Today I am going to demonstrate how to build uh, full auto controlling of water pump circuit at home. My target is to guide people who are almost new in this line so that they can make this type of circuit at home. This figure shows one of several auto controlling of water pump circuit. The left hand portion of this circuit is the power converting unit consisting of a transformer, capacitor, two diodes and one Zener diode, and the right hand portion is the actual controlling circuit of the pump. So one can easily build this type of circuit at home. My target is such. This image is showing the connections of the rectifying portion of the 220 volt AC to 12 volt DC conversion. In this case, two diodes, one capacitor and one Zener diode have been used. The Zener diode is used in reverse direction for protection of the circuit. This Zener diode is 12 volt Zener diode. It means that for or in any case, if the output voltage of the transformer be more than 12 volt, then that 12 volt will pass out through the Zener diode and it will protect the circuit. So Zener diode is highly required for this type of circuit. It is another full auto controlling circuit for water pump. The previous one is somehow bigger than this one. In the previous one, the conversion of voltage from 220 to 12 volt has been done by using a transformer and rectifying circuit. But in this circuit, the conversion of 220 volt to 12 volt DC has been made by an SMPS. The left hand portion of this circuit consists the SMPS, and the right side portion from the 555 timer IC and relay is the main auto controlling circuit of water pump. The previous one is especially applicable for some high capacity motor, but this circuit, the small one which is now showing, is applicable up to maximum half horsepower motor. One can use it confidently for up to half horsepower water pump motor. This image or photo is showing the connections of different legs of any 555 timer IC. The point number 1 to 8 are to be made in some way, which will be shown in my coming figures. So connections are showing in this figure. Here the list of total materials required for making this circuit, having consisting several parts. These parts or materials can be purchased online from Amazon, Flipkart or any other concern, but I will suggest to try to purchase the materials from any local shop, because the price difference is too much. One part, that is the 555 timer IC, in online was 180 rupees, but I have purchased against only rupees 30. So As there is lot of price difference, I will suggest to purchase all the materials from any local shop for economical purposes. Timer IC any triple five, which one is the main material of this circuit, heart of this circuit. This timer IC consists total 8 legs or pins. The legs, number of legs have been shown in this figure 1 to 8. The number of legs are too much important for connecting different parts of the circuit. So the connections are to be pointed or noted at any place before going to making this circuit. At first, all the legs or pins of any TP5 timer IC are to be flattened like this. It will make easy to solder all the connections to this timer IC. So at first, make all the legs flattened as shown in the given figure. Transistor BC547 NPN transistor, it consists 3 legs. The first one, left one, is the collector, the middle one is the base, and the right one, the third one, is the emitter. The collector, base, and emitter pins are to be connected perfectly as shown in my video. These are too much important for making perfect circuit, perfect working of the controlling circuit. 1 mega ohm resistances in this circuit. Two numbers 1 mega ohms resistances are required. Hundred ohms resistance. In the foregoing controlling circuit, only one number 100 ohms resistance will be required. Here two resistances are showing, but one resistance is to be used in this circuit. This one is a figure or image of diodes. Only one diode will be required, 4007, across the two connections of the relay, 12 volt or 230 volt relay. So one direction of the diode is also important, and the diode is to be connected across the relay perfectly as shown in the circuit. Two LEDs, one green, one red, are to be used in this circuit. The green LED is to be used for indicating the power on of the controlling circuit, and the red LED is to be used for getting the indication from the circuit that the pump has been shut down. It will glow when the water will reach at the top sensors at the top water level. At first, connect the two legs 1 and 6 through 1 mega ohms resistance as shown in the figure. The leg numbers are to be marked as shown in this figure 1, 2, 3, 4, then 5, 6, 7, 8. The group cut portion of the timer relay has been shown in this figure. If it will take as upside, then the number of the legs will be same as shown in this figure 1 to 8, and the numbers of the timer IC and connections according to that are very important for perfect constructing of the circuit. Now connect the leg number 2 with leg number 1 through 1 mega ohm resistance as shown in this figure. Connect leg number 4 and 8 by any wire. The two legs 4 and 8 are to be shortened by using any metal wire, and these connections can be made from any side of the timer IC, from top side or bottom side as feasible. Next, connect the BC547 transistor as shown in this figure. The base of the transistor is to be connected with a leg number 3 through a resistance of 100 ohm as shown in this figure, while the collector, the left hand pin of the transistor, is to be connected with the negative 12 volt supply, 12 volt DC supply, and the emitter will be connected to the relay that is showing in the next figure. The base of the transistor PC547 has been connected with the leg number 3 of the timer IC 555 through a resistance of 100 ohm, and the collector, the extreme left pin of the transistor PC547, has been connected to the negative power line of the 12 volt DC supply, and now the extreme right hand pin, that is the emitter of the transistor, is to be connected with the relay as shown in the figure. The other pin of the relay is to be connected to the positive terminal of the 12 volt DC supply. These two pins of the relay are connecting with the operating coil of the relay. After getting current 12 volt DC from the circuit, the relay will be energized and the connections will be transferred from normally closed to normally open, which will be used to operate this circuit. Now connect one IN 4007 diode across the said two pins of the relay, that is in between the positive and negative terminals or line of the available 12 volt DC supply line. The directions of this diode is too much important for this circuit. The diode is used in this case as a safety. It will save the relay and the circuit. If there be any reverse voltage, the diode will save. Now three connections are to be made for three sensors, red, blue and green. One connection is to be made with the leg number 2 of the timer IC 555 for the intermediate sensor, which is to be placed at middle in between the two sensors, top and bottom. The other connections are to be made from with the leg number 6 and from the positive 12 volt DC supply line. The connections made from the leg number 6 is to be used for blue sensors, which is to be placed at the top of the water tank. It will control the circuit for shutting down, or it will maintain the top water level in the water tank. of water in the water tank. The connections from the positive 12 volt DC supply line is to be connected with the rate sensor, which is to be placed at the bottom of the water tank. Now the common point or common pin of the relay, as showing in this figure, is to be connected with the 220 volt AC supply line. If the phase be connected with the supply line, then it will be better for not having phase while the circuit is not working. So connect the phase line of 220 volt AC with this pin as showing in this figure, and the outgoing line for the water pump is to be connected with the pin marked as NO, normally open. Now connect the other line for the water pump with the pin or leg that has been marked as NO, normally open, as showing in this figure. While the relay is not energized, then there will be no current at this line, but while the relay will be energized, then the connections or the current from common pin will go to the normally open line. That means the current then will flow from normal pin or common pin to normally open pin. One line to the pump is going from normally open interlock, while the other line to the pump is going directly from AC supply line. Further, one switch is to be used in the DC 12 volt power supply line to the circuit. This switch will operate the controlling circuit on and off, and two LEDs are to be used in this circuit, that which are showing in the next figure. Connect the green LED across the positive and negative line of the 12 volt DC, which one is used in this circuit. This LED will indicate the power on or not of the circuit. When the switch of the circuit is put on, the LED will glow and it will indicate that the circuit is in condition, the circuit is on. Connect the red LED in between the legs 5 and 7 of the timer IC555. This red LED will glow when water level will reach to the top level where the blue sensor has been placed. The glowing of this LED will indicate that the water has reached at the top level as fixed by the sensor, and the circuit is shut down. Now connect the leg number 4 with positive line of the 12 volt DC that is used for this circuit. The legs or pins 4 and 8 has already been interconnected. So in this way, both the legs 4 and 8 are connected with the positive supply line of the DC 12 volt DC power, which is used in this circuit. Now place the three sensors in the water tank as showing in this figure. The red sensor coming from the positive 12 volt supply line of the circuit is to be placed at the bottom of the water tank. The blue sensor is to be placed at the top of the water tank. It is to be placed at such a level just below the drain pipe of the water tank, and it will maintain the top water level in the water tank. While water will reach at this sensor, the control circuit will automatically shut down, and the green sensor is to be placed in between the blue and red sensors. The positions of this green sensor is too much vital, because while the water will go down below the sensors, then only the water pump will restart. As such, the level of the sensor is to be determined by the users himself, where the water pump is to be restarted, and this the level where the sensor G green is placed, the water level in the water tank will be maximum when the pump will shut down. So the positions of these sensors is to be determined by the users minutely. It is to be noted here that after shutting down pump, the pump will restart only when water will go down below the sensors G, that is the green, then only the water pump will restart. As such, if this sensors green will be placed near bottom, then the pump will be restart only when water will go near the bottom, just above the red. So the green sensors is to be placed in between the blue and not in between the blue and red, as close as possible red, and it is to be determined by the users. Image is showing how the connections have been made from the controlling circuit that placed near the pump and the sensors those placed in the water tank. The connections have been is coming from the water pump, and initially kept in a joint box using for simple electrical purposes 4 inches joint box, and from this joint box the connections have gone to the sensors those placed in the water tank, and the positions of the water tanks will be shown in the next figure, how sensors are placed and connected with the connections coming from the water tank. 3 wires of for 3 sensors are coming from the controlling unit, which has been placed near the water pump through 3 wires. The wires have been placed initially in this joint box, 4 by 4 inches joint box, which is used simple for electrical purposes. And now from this joint box, further connections have been made with the 3 sensors, which is showing in the next figure. In this video, it is showing how the 3 sensors have been placed in the water tank. The connections have been made from the 4 inches by 4 inches joint box, which is placed at the top of the water tank and fixed with some adhesive. The red been placed colored at the bottom of the water tank, while the blue one is just below the drain pipe, and the green sensors about 1 feet below the blue where the pump is to be restarted.